Good. Hello, I'm Adam, and today I'm going to be talking about Python application building and version control, two slightly different topics. But we're going to start off with a little bit of application building using command line parsing using this module called argparse, then get it into a little bit about how we can break up our different codes into different modules and packages to make things a lot cleaner and neater. Very briefly talk about debugging and testing. I don't have a whole lot about that. And then the second half of the class, I'll be talking about version control, specifically with the Git version control system. So starting off with argparse, you should all hopefully have access to this module already. What this allows you to do is simply be able to call programs from the command line that you make with Python, so you can just send off this standalone code to anybody and just give them a set of instructions of how to run a particular code with it. And you can specify certain options in a nice format here, and it will nicely parse all these different functions for you. So this goal is to just build this standalone code base in Python with command line options and keywords. So this module argparse has been built into Python 2.7 and above, also in EPD, so you guys all should probably have it. If you don't, you can just do easy install argparse. And I also had a sample code that you guys can download from the bspace that we'll go through in a little bit, and also the breakout session is on there as well, so if you guys want to go ahead and download that at some point. So this allows for user-friendly command line interfaces, leaves it up to the code to determine what the user wanted. You can be kind of flexible in how you specify these different options, and the code will parse them in a nice way. And it can also automatically generate help messages if you screw up. If you type something that it can't recognize, it'll barf and say, I don't understand what you're trying to say here. Here are the options that I'm allowing you to give. Please try again. There's also a quick note on this older module that some of you may have seen before called optparse, which is basically a similar thing, but it's not 100% compatible, and I think it's being edged out in terms of argparse. So the first step for setting up argparse is to just create a parser object and tell this object what arguments to expect, which can then be used to process the command line arguments during the runtime. This parser class is called argument parser, and what this does is just takes several arguments to set up the description, and using the help text of the Python program. So just starting off simply here, all you do is import argparse, set up your parser object using this argument parser class, and you can give it a little description if you want. And then what we do with our parser object is we go through and we define different arguments that we expect the parser to expect and be able to handle. So we use this function add argument in the parser class, and there are 6 different supported actions, which I'll get into on the next slide. And then once you define all these arguments, the command line entry is parsed by passing a sequence of these arguments that you give on the command line to the parser object. And these will just be taken from the command line by default. So going through the different actions that can be defined, there are 6 built-in actions that can be triggered. The simplest one is just store. What this will do is if you give it a value, it will just store that value into some variable. And if you want, you can convert it to a different type. So by default, things on the command line are just parse as strings, but you can say, I expect an integer here, so please try to convert it to an integer. And if it can't convert it to an integer, then it'll give you a nice, friendly, helpful error message saying that I can't understand what you're trying to give me. Another action is store constant. This is slightly different in that this is just a single flag. So if this flag is set, then a constant will be stored that's predefined, hard-coded into the parser program. Store true and store false are just save the appropriate Boolean value, whether you want this variable to be assigned true or false. Append is a neat one. You can save values to a list. So you can specify several different variables, and they will all be appended to this one list function or list variable. And similarly to the store constant, you can specify this append constant, which will append a bunch of predefined variables within the hard code to the list. And finally, version just prints out the current version of the program and then exits. So there's this. This is the file that I uploaded to bspace that we're going to go through one by one to see these different argument actions in practice. So here we went through the different steps of importing the argparse module, setting up our parser object, parser equals argparse, argument parser, gave it a description. And then we added all these different arguments, giving them the flag that we expect from the command line, the action that this argument is supposed to perform, the variable that it's going to be appended to, which is this destination, and a little help string. Josh, do you have a laser pointer by chance?
I might, yeah. Do you want to say the difference between store and store constant?
Yeah, so store takes the variable that you define in the command line. So for instance here, the command line would be Python, whatever this file is called, minus s to denote that this is the flag I want to parse, and then a value. So I could do Python code.py minus s variable name. And then the string variable name will be stored to the destination simple value. What store constant does is you have a predefined constant here, which is hard-coded into this code base. So all you would set here is this minus c flag. You wouldn't give it a variable afterwards. All you'd say is Python code.py minus c, and then this value store constant would, or sorry, this value to store would be assigned to the destination constant value. And we'll go through what these different things do. So gone through here and defined a bunch of these different actions. We got the store constant, we got the store true and store false, which are the Boolean ones. Append, which appends things to a list. The destination collection, which is the variable. Append constant and minus version. And then all of these results are in this, we can assign all the results from the parsed command into this parser.parseargs object. So these go into the results object, and then they are all values of this object, all attributes of this object, defined by their destination. So if something was stored with this minus s command, then it will be put in results.simpleValue, and then we can print out simple value. Similarly, results.constantValue, results.boolean switch, results.collection, and results.constant collection. And there's also this nice argument help, whereas if we just specify, so this code that I uploaded was called argparseAction.py, which is what we just saw. So if I just do on the command line Python argparseAction.py minus h or minus help, then it will print out all of the different arguments that it can accept, and it will give you a little help string that you defined in the code of what that flag does. So here you see -s simple value will store the simple value you specify here into this variable. So going through these different slides, or these different options here, starting off with store. If we give the command line argument python argparseAction.py -s value, what this will do, and then as you remember at the end of the code we printed out all the different variables that we're storing here. So simple value gets the string value gets stored to simple value. We didn't do anything with the variable constant value, so that's still none. Boolean switch was defined to be false by default. Collection is still empty, and constant collection is still empty. So going on to store constant to delineate the difference between this and store. Here we just give it the flag -c. And what will this do? So this simple value is none because we haven't defined that. So what will the destination constant value be stored as? If I just gave it the flag -c, the constant value to store is hard-coded as the constant that we want to store to this destination. So as we go to the next line, constant value, you see the value has been assigned value to store. Does that make sense?
And that could be anything. That doesn't have to be a string.
No, that can be anything.
Number, it can be a list.
Absolutely. Yep.
It already knows the value that you're asking it to store.
Yeah, that's hard-coded. So this is something like, I don't know, if there's for some reason you want to have a flag that this flag will only do one thing and will only say like, I don't know, like if there's this string that is later used in your code and you want to be able to have a flag saying please assign this string to this value or this number to this value, then this will just allow you to do it with a simple flag rather than having to input the value you want. So this is something like if you, the coder, know that there's only one value that makes sense for this particular variable, then you can set it up this way. And yeah, going back to Josh's point that we can specify what we want, it would be, there's a flag here, like I think it's called type, where you can specify whether you want it to be an int or a float or a string or something. By default, it's just a string.
Yeah, I could imagine maybe making it a bunch of default values. So, but I don't think you can do that.
For what?
Make it the same -c that loads all the default values. Maybe not.
Oh, for the constant store?
Constant value.
For this guy?
The other one is-
Yeah, you can. Well, this one it expects that you give it a string input. So if you look back at the help file, it would say to run this, you do python program.py -s and then type a string, and then it will try to parse that string and assign it to this value, this variable simple value.
But you can retype it within an argument, right? Like you have to type in a string because the command line input has the string.
Correct.
But if you type a number and you say convert this to a float and add argument, it'll do that, right?
Yep. And if it can't convert it, then I think it'll give you a nice error message saying, I don't understand that input. I expected an integer. Okay, so store true, store false. These are just Boolean switches. Here we see we can give it a default value if we want. So here the default is false. So if we set this flag -t, then it will change this Boolean value to true. Does So you see the Boolean switch is now being printed out as true. Append, this can take a series of entries on the command line, and then it will append all of them onto a particular list. So these will all go to the list collection. So here our command line input is Python argparse action.py minus A1 minus A2 minus A3. So then these strings 1, 2, and 3 will all be appended to this list collection. So when we print out the list at the end here, you see that they have all been assigned to this collection list. And similarly, append constant, here we define hard-coded what the different values that we can append are. So again, these are just single flags. We can't specify a variable afterwards. And these will append these different predefined constant values to a list. So here we can do Python argparse action.py minus b minus a, and then this will append the predefined constants to this constant collection list.
And you can put multiple A's and B's there and allow them to move on to the list.
Mm-hmm.
If you do TFT, it'll end up being true. If you do FT, FF, it'll end up being false. It's the last one that occurs to our person.
Okay. Good to know.
Is there a way to get it to give you an error if you press like minus something?
Yeah, I think it'll do that.
Yeah, there's actually, that's one of the reasons why this is, and we're using this and not the previous version of it because it does better at error handling. So it'll throw, actually, if you just look at, you just print out parser, the instance that you created, it'll actually show you what error handler it uses and how long to deal with it. So you can overwrite that. And you can say, in the case that foo has been set to a constant by two different arguments, take the second one and ignore the other one, or throw an error and do that. You can set all that stuff.
And finally, you can specify this version flag, which will just print out the current version of your code. So you can update, if you update your code and send out someone else, or send a new version to someone, you can say that this is version 2.0 or 2.1 or whatever you want. So that's argparse stuff. Does anyone have any questions on this? We're going to be going into a breakout session where you'll be able to deal with all these different things and try it out for yourself.
I think it's also worth pointing out the nargs keyword. So you can set nargs equals to a number like 2, which basically, let's say you want to put a latitude, longitude, and you want to say minus position. And you want to force them to have to do 2 numbers after that. You can say nargs equals 2, and then it'll save that. You can also do nargs equals question mark, and then it has an arbitrary number of inputs after that. So nargs is pretty useful.
Okay. So now we're going on to modules and packages. This is a nice way of being able to better organize your code once your code starts becoming large and unwieldy, because you just can't keep everything in just single standalone code files all the time. You're eventually going to want to be able to have all your code communicate with each other nicely. And put things in different folders to make sense based on, say, I want to group all my code into a bunch of plotting stuff, and then I group another block of code into some other thing that we're doing with databases or something like that. And then we can communicate back and forth between all our different code bases in a nice, easy-to-use format. So you have functions from other codes made for different reasons, might be useful elsewhere. So say we make a plotting code for one thing, and then we eventually start doing another project, and we realize that the plotting code that we wrote for our old project could be used for this new project. Then we can call that module and be able to reuse it over and over again. So it's useful to break up our code into modules and packages, whereas a module is just a file containing predefined functions and variables. And it must just have a .py extension. So, I mean, this is similar to what we've been doing all along with the Python standard library. So we can import these modules just by saying, you know, import plotting, or, well, we've done everything with matplotlib and whatnot. So you do import matplotlib, or from matplotlib import pyplot. These are just instances of functions within modules that we can import to our code base. So, in order for these modules to be able to be called correctly, we need to set up our paths correctly, so that if we're trying to call our different modules that we've created from anywhere else on our computer, if we're not in the right folder, we need to know, Python needs to know where to look for your code base. So you have to set up your Python path in your environment variables, so that Python knows where to look for your code base. So I'm not going to go through all this, but you can read this at your leisure. You basically just need to set this Python path environment variable to the correct path to where your code lives. So if you have a bunch of Python code in this directory path to your code, then you just set this as your Python path, and then you'll be able to, when you initiate a instance of Python, be able to import all of the different code that you've written in a nice, easy way. You can also check all this within Python and append to your path if you want to do this on the fly within Python. You probably won't need to do this very often, but you can at least check to make sure if you're getting path errors or something like that, you can check to make sure that your path is set correctly within Python to see where it is looking for your particular path. So if you import this sys module and then print sys.path, it will list all of the places that Python is currently looking for code to find all the modules and functions that you've predefined. So here there's 2 different paths set here, which I've called predefined Python path and path defined by environment variable. So these are, it will list all the ones that are pre-built into Python where it's looking within its own structure, and then also the ones that you've defined by yourself. You can also append this list if you're if you want to add a new path within your within this current instance of Python. You can just basically just add to this list, and then this will be added to your path. But this goes away once you close down Python for this instance. So if you want something to be permanently within your Python path, you'll want to set it up as your environment variable.
One other thing about that.
Yeah, of course.
The thing to also recognize is that you may have a code that you're writing called, you know, my code for my lab, and that's got its own sort of set of directories. In the code that you run, you may want to not sort of modify the Python path directly, but you might want to look at an environment variable called my big code base or something, and then append inside of Python, you know, something that uses that as a stem, so that you now have, you actually tell Python while you're running, oh, and by the way, I have another code base which I want you to look at. You may not want to have to directly hard code your Python path to add all of the different things that you're going to be building and running. You may want to do that within a separate code, so you can see over here.
Oh, great. So now, briefly on the packages, if you have this path all set correctly, then your code can be broken up even further into reasonable folders and imported as necessary. You can either import all of the modules within a package, or functions or classes within the modules. And really all you need to do for this is just break up your code into separate folders. Say you have an analysis folder with two different modules, data cleaner and data generator. And then you have also a plotting module with different modules, histogram and scatter plot. All you need to do is just place a blank, like nothing in it, just underscore init underscore .py within that folder, and then you'll be able to import different functions from these different modules within that folder. So if we want to import all of the different functions from this file data generator, all we need to do is do import analysis, which is the name of our module, our package for analysis, .data generator, which is the name of this file, and then we can shorten it if we want as DG. And there's also, say there's a function nice hist within this histogram.py program, then we can just import that individual function if we want from plotting.histogram import nice hist. And then we can call all of these different functions that we've imported with the example my data equals dg.generateData, where generate data is a function within the data generator program. And then we can do nice hist my data. So this is just a nice way to break up your code into a bunch of different packages for cleaner use. And very briefly, there's I won't go too much into this, but there's a way called distutils to package up your all of your code base into a nice format for to bundle it up and for easy use by others. You can just create a setup.py file using these distutils things, which allows others to install your code in the standard fashion where they just do Python setup.py, and then it will install all of your code base together. This is a bit more complicated than anything I want to get into, but I just wanted to throw that name out there so you guys could look into it if you want to. Do you have anything more to say about distutils, Josh?
No, but I mean, if you're going to be making standard packages, that's going to be used.
Yeah. Okay. So briefly about debugging and testing. This standard technique, or maybe not standard, but the technique some people use to debug code by inserting a bunch of print statements inside your code to see what's going wrong can be inconvenient if your code takes a long time to run. So there's this module PDB, which is an interactive source debugger, which allows you to step through all the different parts of your code and see what's happening at every given step. And variables are preserved at each breakpoint, and you can step through lines of code and see what variable is assigned at what place to see what really is going on within your code. And this is especially easy within IPython, because if your code crashes and it gives you a nice, it spits out a nice error message, and you can just type out type debug, and it will set you into this IPDB environment where you can step through and see what the code is doing wrong. So I think I might want to give a little demo on this, just to briefly go. this so I can see what I'm doing. Yep.
Do you want to tell through?
Yeah, I was just going to put a an error in the code so it'll crash and then try to step through and see where it crashed. But I realize this might not be the best one to do for this, so file.
So Fernando's, instead of doing print statement is to put a 1 divided by 0 in places he would have put print statements.
Oh, really? I just raised exceptions.
Yeah, so it raises numerical error exception. And that's his way of doing the inspection into his code when he breaks, when he knows it's breaking around there.
Right. So save this as so all this code is doing is let me just do print here. Taking these two variables and then trying to convert them into integers and then printing them. So I got a value error here, invalid literal for int with base 10 hello. So all this is telling me that I don't understand this variable. This int string is crashing. I can't do this action. So if I do debug, then it'll bring me into this IPDB environment, and I can see what the different values that are stored in this environment are. In my code are. So I can type just print string or print number string. Why is that not there? Oh, because that. Oh yeah, maybe. Run. Oops. There we go. So I can go through these different variables and see what they are. So I can see that number string is assigned to variable 5, which Python will be able to handle and turn into an integer, but it can't turn this integer string into, can't turn this string hello into an integer. So we can see that's why it's crashing. I will just go back to my code and get rid of this, exit out of IPDB with just Control D, and then I can do this, and it will print and run correctly.
So Adam,
Yeah.
even if you don't go into debug mode, you can still have IPython tell you what's in those variables.
Oh yeah? How's that?
You just query it, stuff that you run, you then have access to. But it can't go within functions.
Okay, that's probably.
So I was wondering, can the debugging mode, can that take us within?
Yes.
Inspect the variable function?
Def.
Yeah, like that.
Right. So going back and making the code crappy again, assigning our variables here. So I do run untitled.py and sorry, import import untitled.
Yeah, you gotta run it. You
Yeah,
gotta-
this will work. Untitled dot. Oh right, I've got to call it in here. Right. There we go. Untitled dot. I've got to reload here. Okay. And now untitled dot assign in print. There we go. Now debug. So yes, we are here within the print stuff function. And we can also go up and down to go through the different functions with U and D to see where in the different lines of code these things are being assigned. Does that make sense? So it allows you, especially if you have a really complex code that's calling tons of different functions, you can step up and down through all the different parts of the code and see where exactly a particular variable is being assigned. So since I stepped up here, I see that the string hello is being assigned within this assign and print function. Sorry, within this print stuff function. No, it's being assigned in the assign and print function, and then being printed in the print stuff function. So I can either go back and change this string to something else, reload it, and then print. It will work fine. So that just allows a nice, easy way to go back and debug your code on the fly. Okay. So now I was going to have a breakout session. Did you guys able to access the breakout.zip? Okay, so there's this file breakout10.zip, and within this, once you unzip it, there's a couple directories and also a function. There's also a file called breakout10.py, which is currently empty. What I want you to do here is not to modify the other files in the other folders, but you will need to use them. So you'll want to use the modules and packages stuff that I talked about before to be able to import stuff from these different folders in order to run the breakout10.py. And then want to build up a command line parser which allows the user to specify how many data points to generate. So there's a function called, one of the folders has a data generator file, and then it also, one of the other folders is plotting, and you'll be able to define how you want to plot it. So basically I want this command line parser to be able to specify how many data points you want to generate. Down here you see the flag -n200, so that's saying I want to generate 200 data points. And then there's this flag -t, which will say whether I want it to be plotting a filled-in histogram or an outlined one, and also be able to specify the title of the plot with this -T flag, and then have the plot to be generated. Make sense? Okay? Have fun. So I'm just going to go really quickly over what the answer should look like here. So to start off, because we had this breakout 10 folder, we had our file breakout10.py and these two subfolders, datagen and plotting. I can get rid of these. So you see, in order to be able to import datagen and plotting into my breakout10.py, I had to put this __init__.py into each of these folders. And then I built up the breakout10.py, which imported these things. And I'll go through this line by line in a sec, but I just want to demonstrate that this works. Hopefully. So if I do Python breakout10.py -- help, I'll get a nice friendly help message, maybe. Hello. There we go. Saying how to use the code and what all the different arguments are. So we see that I have this flag -t, which if I flag this, it'll be true to use the unfilled histogram. If it's -f, then do not use the unfilled histogram. -n and variable data n will store the number of data points to retrieve from our data generator function, and then this -T title will store the title for the plot. So if I do this command Python breakout10.py -t, so this will be an unfilled histogram, -n 200, so I'll get 200 data points, and then -t my awesome title. And you see I had to put this in strings because, in quotes, because otherwise it would take it as 3 different arguments. Then press enter, and I should hopefully get a nice unfilled histogram of random data with the title my awesome title. Let's see if I add a -f at the end. See if Chris was right. That'll take the last one. Yep. So even though I had the -t and -f, it'll take the last flag that you give it. And let's see if I give it an argument that I didn't specify I could take. It crashes and says unrecognized argument -g, and then gives me a nice little instruction again of how to actually use the code.
It's not actually crashing, it's just exiting, and that's the way that the default exit is.
Sure.
So you can, again, you can overwrite that. You could have it email your parents if you want.
You should do that for your homework. Every time your code crashes. Yeah. Okay, back to off mirroring. Okay, so yes, here's going through the code that I did to achieve this. I place those blank init.py files in the datagen and plotting folders, and then I want to import the function randata from the datagen.generateData module, and then import the outlined histogram from the plotting.histOutline module. So now I have those tools at my disposal from those different folders. Everything is communicating nicely. And I also import the regular histogram, import argparse, import pylab for plotting purposes, set up my parser, add the argument -t, which will store true. This is a binary switch. Unfilled histogram to true. With the -f flag, it'll set unfilled histogram to false. The -n is just a simple store action. You can set a default. Here I have as a default of 10 data points. Send it to the destination data n, and you see that I specified the type as integer, so it'll try to convert it into an integer. And then here's another store action, -t, with the default no title, the destination title. Take all the results from the parser into the results object. Then I get my data from the function randData, feeding to it the results.dataN from the parser, which is just the number of data points I want. Then if results.unfilled histogram equals true, then we do the unfilled histogram plot. Otherwise, we do the regular histogram plot. Make sense? Any questions? Yes?
So if we didn't put the dash n flag, we put a number, I wouldn't know that it was 10.
Yeah. So let's do that. Oops, I still have that bad one. Oh, sorry, thanks. Yep, so there's just 10 data points there. And also, since it's trying to convert it into a number, if I feed it something that it can't convert into an int, then it should just exit with a nice error message. Invalid int file, blah.
So I didn't do anything to my path. I didn't like you can either, but I can't import from that. I did put the
Are you within the, yeah, I didn't change my path. I just did this all within the directory that breakout10.py was in. And you're still getting, okay. Well, that happens. Let's do another one of these. That's sad.
Google provides services on a wide range of devices, from desktop computers to mobile devices, including tablets. But we've long neglected one of the most popular computer systems ever sold. And I'm here to introduce Google Maps 8-bit version as a first product for NES. Well, first we developed a new type of cartridge with dialogue technology, allowing the NS to connect to Google. We run more than 100,000 servers to overcome the NS's technical limitations. 8-bit maps are generated by Google's cloud in real time. It's really easy to use. Insert the cartridge, connect the cable, and turn the power on. Blow on the cartridge to start, and you're automatically connected to the internet. Let's start from the title screen. Select search and enter the name of the place, just like the regular Google Maps. You can of course search a route to your destination. You can also search with your voice using the Path to mic. Google Maps 8-bit version will soon be available in Google Store. But for now, you can play the trial version by going to Google Maps and click the Quest button on the top right corner.
Yeah.
I was super confused.
Okay.
It works. Crazy.
So, okay, now on to Git. So the goals of this talk, you guys have, or many of you at least may have seen Git introduced at the boot camp, and I'm sure some of you already use some kind of version control. But I think it'll be worthwhile to go through this again, especially for those that aren't actively using version control in their everyday lives. So if you're not using version control, I should hopefully convince you that all of you should start using version control now, and give a little cookbook method of how to use a very specific set of Git-centric tools to get started, and then point in the right direction for more use. So going back to this, this video game analogy, say we want to play Google 8-bit version. In the very old school state of video games, there were no save slots, and if you died, that was just game over. So that sucked. You had to start all over again. Then we eventually got to one save slot, but there were pitfalls of this. Like, what if we wanted to go back to a previous save state? What if we wanted to revisit a special part of our game that we want to revisit over and over again, or go down a different path that we could take? Or worse, what if the game is unwinnable? What if we go down some dungeon that we can't escape from, and then we save our game, and then we can't go back and fix it? But then comes new technology. We get video games with multiple frequent saves, security, which gives us security to avoid lost progress, and the ability to return to earlier states and choose to go down new paths. So this is kind of the mentality that we want. Does anyone recognize this game? Is it? Could be. Okay. Is that Half-Life 2? Okay. That looks like my cubicle? This is the game of life. So yes, it saves it very often, and this is the mentality that we want. We want to save early and save often, and have all of our previous save states available for us to go back. So this is the kind of idea for version control. It allows us to have a management of all the changes to the programs that we make, to documents and other computer files. Gives us all these different checkpoints of the evolution of the source code. So if we have a particular place where we want to branch off and explore new routes with our code, we can do so, keeping all the old code the same. It's also a nice way to back up, store, restore, and synchronize all of our code. See what the different changes in the history of the code was, and also allow for collaboration on a single code base with multiple users, and finally to maintain sanity. So here's a nice little plot illustrating this. We have this code quality per development per hour, which I got from Peter Williams, a grad student in our department. As time goes on, we want to be able to feel free to experiment without fear of breaking our existing code. Here's a very embarrassing slide of what I used to do for primitive version control. I basically just saved a bunch of different instances of the same code over and over again, just calling it a different letter each time. So this way I maintained the ability to go back to an old version of my code if I wanted to, but it quickly was spiraling out of control as I made lots of different changes. This was my undergrad, don't worry. This was before I saw the light. I also had some Fortran in there. That was even worse. So we want to avoid that. I mean, that's still better than nothing, but we want to be able to do this in a better way. So right now I'm going to go through a bunch of terms that are commonly used in version control, specifically with Git. So we have this repository or repo, which is this sort of central database that's storing all the versions of the files and also keeping track of all their changes. So this repo contains all of the past versions of your files and notes all the different changes that were made between them. There's a server, which is the computer storing this repository. A client is the computer connecting to the repository. A working copy is a local directory of this repository where we make all the different changes to our files. And this word trunk is a primary location for all the code in the repository. Now some different actions we can do. Add is to begin tracking a file by just putting it into the repository. We do that in a special way. Revision is the current version of a file, whether it's version 1, 2, etc. And the latest of these revisions is called the head. And to do this action called checkout is to download a file or files from this repository. So if we want to check out a particular file or a particular bunch of files from a repository, we do something called a checkout. To check in or to commit is to, after we've made changes to the file, we want to upload the change file to the repository and give a nice little commit message saying what we've changed. We can do an update or sync, which will basically swap the different files and make sure that we have the current repository updated and meshing nicely with our current working directory. And there's also revert, which we say, screw it, I don't like anything that I've done, I'm going to revert back to the repository state and get rid of all my changes that I've made locally. Some more advanced terms or things that you can do are to branch. So what this is kind of going down a different path, say going down a different cave in your video game. We basically create a separate copy of a file or folder for private use, and then we can go experiment with it and play around with it and see if we want to develop or commit the changes after the fact. We can find the differences between two files using the diff command to see what has changed between two revisions. Merge or patch to apply the changes from one file to another, bringing it up to date. Conflict, obviously, is when changes contradict each other. This can sometimes happen when you're working with another person on the code and you both try to edit the same part of the code. And then if you try to merge those things together, it will create a conflict saying, I can't merge these, you've tried to edit the same part. And then if this happens, you'll have to resolve the conflict. So there are two main breakdowns of different types of version control systems. There's centralized and distributed. Centralized code or version control systems are like SVN, what else? CVS, I think, was centralized. And then distributed are sort of newer ones like Git and Mercurial. So with the centralized ones, we have all of the revisions existing on a single server. So we have this this nice computer somewhere that that contains all the different revisions that have ever been made to this code. And then any user that wants to access this code will have to check out a particular version, make changes to it, and then commit the changes back to the central server. And so that all that exists on the user's computer is just the current version of things. So what this requires is that you have communication with the central server at all times if you want to be able to commit new changes or pull back other changes that other people have made. You just basically need to have communication with the central server. With a distributed framework, you clone the entire repository. So you take everything and put it onto your local machine. So on your local machine, you have all the different history of everything that has been done to that repository, and you basically just have everything at your disposal locally. So you don't really need communication with a central server since everything is local. So you can, make changes and commit changes to your local repository while you're flying on a plane and you have no internet access. And then later on, if you want to be able to push to a central repository so other people can access your code, you can still do that with these push and pull actions to pull to and from a central repository somewhere. But it's not necessary. You can do everything locally if you want, which is really nice. These are just illustrations of this. I won't really go through these. So there are, I think in my opinion at least, and I think in a lot of other people's opinions, I used to use SVN, but which was a central repository, a centralized VCS system. But I quickly got turned over to Git because it's got these advantages of a distributed version control system. With centralized, history modification is difficult. It's hard to go back and change history should you want to. As I said before, you require network communication at all times if you want to do any actions. And because of this network communication, everything's a lot slower. But with a distributed version control system like Git, everything can be local and everything is a lot faster because of it. This is a list of a few different brands of version control systems. CVS back in the 90s, Subversion, which is what I used to use, SVN, and then a bunch of these new ones came out around 2005. And the one I'm going to be talking about today is Git. Where did that name come from? Does anyone know? It's pretty awesome. So, I'm going to, what's that? Getting started. Yeah, we'll go with that. Yeah, it is. Yeah, I think so. Do you know why he named it that, though? Okay.
Why are we even having this conversation? We're all on the web. We can find out.
There is a coding thing that you need this after yourself and you tell the question. I'm pretty sure it's not. They either mean every caption, which is not.
Oh, what? Okay. So yeah, so now we can just go through different steps of Git. You should hopefully all have it on your computers now, so you can kind of follow along with this as we go. Version control of your files is very easy to start up locally. All you need to do is initialize a repository, so you go into a particular folder that you want to start version control in, add some files to it, and then commit changes. So we can start off by just going into a folder we call My Software, which we now want to start putting under version control. We initialize the repository using the command git init. And that should print out a nice little message saying that the initialization was successful. But if we do ls-a in that repository, you should see that this file .git has been created along with all your other files that you may already have in that directory. That is what keeps track of all the different history. This is, I think, a folder of all the different history and modifications and such, and all of the past versions of the code that have been created under this repository. So if you don't have any files in this folder yet, go ahead and add a few files in there so we can add them. And then if you want to just add all of your current files into all the current files in the My Software directory. Then we can just do git add dot, which will just add everything that's in that directory to.
So it doesn't automatically.
No, you need to specify that you want this particular file to start being version controlled. So if you just have if you have a file in there that you didn't do git add to, then it will just stay as a normal file. It won't be version controlled. Any changes you make to it won't be tracked. So you need to add it as you go along. If you create a new file, you need to do git add to that file. And then you do git commit -m. The -m is to give the message of what you've changed. So you do git commit -m, and this is just the message initial import of all my files. And then it prints out a nice little message of all that. Did people get that to work? Are there any problems with that? Yeah?
So what's really the distinction between adding and committing? Or, I mean, I get the different.
Yeah, no, sure. So add is it is a type of change that is to be made. So I say git add file.py. That means I want file.py to start being handled under version control. And so that is a change that I've made. And then if I want to commit that change, then I need to do git commit -m, and then the string added file.py. And then, so the commit is what you do after every change that you make. So then if I were to go into file.py and add a few lines of code, then I would do git commit -m and the message added some lines of code. And hopefully a more descriptive message than about what those lines of code do, but that's the idea. So there's the actions. The action commit is to commit any changes that you've made to any files in that directory or the addition of new files to that directory. Does that make sense?
Yeah, so if you're sort of adding a file, you make a new file, you realize you want it to be in the repository, you add 2 more, the next day, and you haven't committed anything yet. You just say commit -a, git commit -a, and it'll basically add everything and commit everything that you just said that you wanted to add. And it doesn't have to be just now, it can be everything that's queued up.
Right.
So we usually present them as this line and this line, but they don't have to be sequential.
So the basic workflow is, I mean, it's just very nice and easy. You modify your code and document, you commit changes, and then you repeat. It's really all there is to it for a very basic workflow of Git.
You don't have to specify which file you want to commit changes to.
You can. If you, yeah, so you can. If you only want, let's say you've made changes to file A and file B, and you only want to commit the changes to file B, then you do git commit B, say it was b.py, and then -m text message of what you've changed to file B. So that will leave all the changes that you made to file A uncommitted for you to commit at some later date.
Actually, I think there's also get GUI, or you type get GUI, and it actually makes, I feel like it makes that stuff a lot more fun.
Oh yeah, I was going to go into graphical user interfaces at some point. I've not used Git GUI, but yeah, I'll give it a demonstration. All these, unless you really like using command lines, all this can be done a lot easier with the GUI. But I think it's useful to go through the basics of the command lines at the beginning. So yeah, going through we can go through some of the different actions that we can do here. Starting off with the add action. So I'm creating this file readme on the command line echo. This is the readme. Pipe it into the readme file. And now I want to add this readme file to start being version controlled. So I do git add readme. So this is saying, instead of doing everything that has changed, I specify that I want just to add this particular file. And then git commit -m added a readme file. And now that has been filed. Now that it has been committed. I can also remove a file from. Do you have a question?
Yeah. So if you in the top, if you then change readme again,
Yeah.
and then commit it again,
Mm-hmm.
do you need to either add it again or use -a?
No.
You don't.
No. Then you just do git commit readme minus m.
What if you just wouldn't, okay, what if you just said, because I've tried, what I used to use recurring on many times, because I still like the syntax thing.
Okay.
So if I just said git commit dash m, like change readme again, but didn't say git commit readme, would it not know to commit?
I think you'd need to specify what file you want to commit.
Or use dash
Or use
a.
-a, yeah.
Okay, that's the difference.
Yeah. Because if you use -a, then it'll do all the changes.
Okay, if you don't do that, just wait for you to tell, but,
Yeah.
okay.
So the opposite of this, if I wanted to delete a file from being version controlled, I can do git remove, git rm useless file.txt, or recursive remove of a directory, git remove -r. Kind of annoying, but if you want to rename a file, then you need to sort of do it sort of does a delete of the file and then adds it again. But you can shorten this with just the git move command.
Doesn't matter if you just delete old file committed, add, the new file name. Doesn't matter if you get moved around.
I think the move is exactly the same, but I'm not 100% sure. But I think it is actually the same as just adding and deleting in terms of how it logs it or whatever. So all of these commits that you have made are identifiable by these things called sh1 hashes. So there's these long string of numbers and letters that identify each of these particular commits. So if you do the command git log, you will get all of the recent commits that have been, all the recent changes that have been committed to the repository, along with a message about them. So you get the commit hashtag, the author who did the command, who did the committing, the date, and the comment that they associated with it. So we can go through and see what the current status of our repository is by doing git status. This will let us know if any changes to particular files have been made, or if files have been added but not yet committed. So this git status command will say, you have made changes to file X and file Y, you have added file Z, but they have not been committed yet. You can also, so that will let you know what files have yet to be committed, so you can do that. There's also git diff, which is a way on the command line to see the differences between your current working copy of a file and the file that you got from the repository, so you can see what changes that you had made. So here we see, after I get git diff of this file mystuff.py, we see that I have removed this line and added these lines. However, as I said, unless you really like working from the command line, there are GUI tools which make this process a lot easier. The one I have used and had a lot of success with is SmartGit, but I'm sure there's many others that some people might be able to recommend to you. I gave a link to a bunch of different GUI interfaces that you could download, but I found SmartGit to be pretty good. I think it works on Mac, Linux, and Windows, so it's pretty flexible in terms of that. So I was going to go through a little demo now of how to use SmartGit for doing the things that we were talking about. huge. Yeah, SmartGit runs on Mac. And everything, yeah. Did that work? Okay, anyway. So here you see my base directory is this Q repo directory, and I have it within it a bunch of different folders. You can also put papers and stuff under version control. But here, let's go through some of my software directories. As you can see, I treat all these different directories as modules. I got the init.py in there, so I can easily communicate all my different code back and forth between them. Within SmartGit, I can pull up a log to see what different changes have been made to a particular file and when. So here I have the commit messages for each of the different commits that I made to this particular file. And you can also scroll through, and they have a little differencing thing here that shows what changes have been made between these two different versions. So looks here like I just modified a couple keywords and added a few lines of code there. So let's say I want to open up this file and make some changes to it. And then save that. Close it. And then SmartGit will notice that this file has changed. It'll show up as a little orange picture here saying that this file has changed and needs to be committed. So if I want to see what I changed, if I am not quick with my commit, I can go ahead and changes and see what I actually changed here. This pulls up a little GUI showing the differences between the file that I got from the repository and my local copy. So you can see it just shows here that I added a nice comment here. So that's fine. Now I want to commit this file. So I just click commit. And then hit commit. And there we go. Everything is committed, and we see that my sorry, where's that? Oh, that just what does the index stand? I don't know. Did that show up as change when I changed grid plot?
It hasn't changed. It's only been unchanged.
That might be, is that if the repository version is changed? No? I don't know. I'm not sure what the next state is.
Worth pointing out also that it's not, those PYC files, the Python file files are not part of the repository.
Right. There's a file that you can specify within your Git repository. Called ignore. Right. So there's this git ignore file that if you put this in your main Git repository, this will say, I don't want to ever worry about any of these types of files. So I never want to be able to commit a .pyc file because that's just, a compiled whatever. Bibliography files, building files. I also want to ignore some of these image files that constantly be created. This just allows me to say that these files are unimportant to me and I don't want them to be version controlled. So if you put this .gitignore file in your main directory for your where the version control is happening, then you could ignore all those different types of files.
Question about that. So I usually do the same thing. I ignore all of my data files. Is there a good way to carry around the data files if you want it? I want to give my repository to somebody else. I definitely don't want the data file to be version controlled because then there's the awful and using that place. How do you guys normally pass around the data? You just have a separate directory for them?
Very good question.
It'd be really nice if I could add it to Git in a way that doesn't version control. Like, I want to push it. I want to be able to like have it carry along, but definitely never version control.
Yeah, so you just don't have all the different copies of the file?
Well, just don't commit any changes to it.
Yeah, but what if you do make
Well,
changes to it?
So we have, I'm using some, GitHub or some other repository. I want other people to be able to download my data files. So the way I do it right now is I just separately completely on the data.
Yeah, I mean, this is a very hot topic. Okay. To try to understand how to do this right and robustly, and where you're not unnecessarily moving data around. But by the nature of what you're asking for, is essentially you want a hybrid, centralized repository that's serving the big data, and you want a distributed system that's got all the code and all the stuff around it, which is not, it's not ridiculous to think about that we may actually go that direction. But likely what you want to do is you want to basically have a big file called, execute this if you want the code. And then the data, and then it actually goes to some central repository, pulls in the data for the person locally.
I think that's me with all this. There's something where I have my data on my computer. I just give somebody else, a bundle of my repository, and I give them my data directly. This is how I currently do it. Or right now I have a central repository, right? And I also I don't know.
Yeah.
Yes.
No, it's not a solved problem. Okay. And so any sort of hybridization or something you're already doing is probably the best way to do it in this way.
Yeah, I particularly get into problems with that when doing shared papers and stuff, because those images can get out of control too. Like when you make a lot of changes to, any image files or EPS files or something like that, you don't want to, you're constantly making changes to them, but you don't want every version of that file to be saved, because then you just get huge repositories.
Can you set user permissions for who can commit specific files?
I don't know.
Gitolite does that.
Gitolite? Does that? Yeah, I use Gitolite as well, but I don't know if you can specify what files or just what folders.
Oh, no, it's just repository.
Yeah.
It's just what we were right now.
Right. All right, let's just have one more of these. What is going on?
Since our founding in 2005, we at YouTube have continually strived to bring you the best possible video experience on the internet. But that is all about to change. Our latest innovation gives you a way to literally hold YouTube in your hand. Introducing the YouTube Collection on DVD. It's the complete YouTube experience, completely offline. Enjoying YouTube videos has never been easier. With the YouTube Collection, DVDs have been conveniently organized into a system of nested modules. Simply navigate through the modules until you find the DVD of your choice. Each DVD menu is populated with video thumbnails. Just like on YouTube.com, you can select your playback resolution. And yes, full screen mode is available if desired. The YouTube Collection doesn't require the internet. You don't lose interactivity. Just fill out the comment form and place it in one of the self-addressed stamped envelopes. Don't forget to throw in a green thumbs up or a red thumbs down. Your feedback will be sent directly to the creator of that particular video, so you can maintain the dialogue that you're used to. The YouTube Collection isn't just a sampling of YouTube, it's all of YouTube. Every YouTube video uploaded ever. As soon as you sign up, we'll dispatch a fleet of 175 YouTube trucks to your home. Your nested video modules will arrive securely on pre-categorized a steep grade or in an area with low overpasses, your DVDs will be delivered by pack mail. Since approximately an hour of video is uploaded to YouTube every second, you'll receive a new truckload every week. And if you sign up now, we'll give the entire DVD library to a friend or relative of your choice, totally free. Visit youtube.com/YouTube collection. Order now and select from a number of free add-ons, including trending videos on Laserdisc, free soundtracks on vinyl, or weatherproof exterior DVD shelving for when your collection gets too large for the inside of your home. Order the YouTube collection on DVD. Simple, economical, convenient. A whole new way to enjoy the videos you love.
Amazing. Reminds me of Gmail paper a couple of years ago.
Was that last year? That was last year.
Was that last year? I don't know. Yeah, they had a lot this year. I think there were several others, like Google Racing.
That was cool.
Yeah.
That wasn't real?
Should be. Oops.
Self-driving NASCAR.
Self-driving cars are real.
That would be
Okay. Now on to collaboration. Git makes it, or any version control system makes it really easy to work on a single code base or document with multiple people contributing. Or similarly, as is usually the case for me, one person developing the same code on multiple computers. So I have a bunch of code that I want to run on different computers, or be able to edit from my laptop, or from a work desktop computer, or from my home desktop, or whatever. Or be able to back up my code as a side to this every time I commit and have it pushed to a central repository somewhere. All that code is saved in case my laptop breaks. But we also just want to avoid this, emailing each other back and forth different versions of a paper or of a code base or something like that. So this way allows us to easily see what has changed and when, and be able to do all the merging of all the different changes behind the scenes. And if any conflict should arise, which hopefully they won't, unless you're both working on the same line of code or the same paragraph or something like that of a paper, then we can deal with those merge conflicts as they arrive. So in a distributed version control system like Git, cloning is a standard operation to get files. So as I mentioned before, you just you clone the entire repository onto your local computer into a particular folder on your local disk. So as I said, cloning is useful for backups, even when you're not collaborating. In order to clone a repository from somewhere else, you do this git clone action. So you do git clone, and then the path to the other computer, and then the path to the files containing the repository that you want to clone. And then from now on, you can pull the state of the files from this other computer to the one you're working on now. So if someone makes a change on that other computer, and then they commit their changes, you can pull those changes to your local computer to get the latest updated version of that code. So from the computer that you're working on now, you commit your changes, then do git pull from the other computer to the path to your current working version. So these projects have to be hosted somewhere in order for you to be able to communicate with them from anywhere. So because Git is a distributed system with everything being local, in order to be able to push your projects back, any changes that you have made back to a place where other people can access them, you need to be able to use this command push so that you can push all of your changes to a central repository somewhere that people have access to, and then can pull your changes. In order to avoid confusion, you only want to push to something called a bare repository. And the bare repository is just something that has no working copy. It just contains all of the changes that have been made to Git. So it's not a place on someone's computer where they're actively making changes to. It is just, its sole purpose is to act as a folder containing the latest updated version of the code. So you can set up one of these bare repositories on a central server that maybe everyone has SSH access to, so that they can push and pull to the central server. Or you can, there are also many free hosting sites if your code is public or open source. And one of the most popular ones of these is called GitHub, if you guys have heard of that. As part of the homework, we'll have you create a GitHub repository so you can play around with all this. It is a Git repository, but it has no working file. So it doesn't have a working copy of the latest changes.
You don't create it in the same way that you...
No, there's a special way to create a bare repository. You can just... I can't remember, but it sounds right. But yeah, and that... yeah, so basically you just don't want to make any changes of the files in the bare repository. You just want to leave it be. And then the way you communicate with this bare repository is with pushing and pulling. So once you get this bare repository hosted and created on a separate server, you can clone the repository to your local disk. The first action you always want to do is pull, just in case someone has made changes to the repository, and then push any new changes that you have committed on your local repository to the server. So here I'm creating the folder my clone, which is where I want my repository to be. I do git clone, and then the path to the repository, it can be, git at github.com. Codaset no longer exists, sadly. And then the path to the Git repository. And then it will clone all of that information onto your local disk. Then you can make changes to the files in this repository. Change a file, then do git commit -m, long descriptive commit message. Once again, you pull to update to the latest version of the code, just in case someone has updated the code while you were working on your code. This is just a safety to prevent merge conflicts. Do git pull. If there aren't any merge conflicts, you resolve them as necessary. Otherwise, then you can just do git push to push the changes that you have made locally to the central repository so that others can access them. So conflict sometimes arrives. Generally, Git will happily deal with multiple workers on the same file and merge the changes automatically. If, for instance, Alice was working on line 10 of the code and Bob was working on line 50 of the code, and they both made changes to each of those lines, and they both committed those changes and then both pushed to the repository, then Git should be able to merge them correctly, as long as they do this, are good with how they do the pushing and pulling operations. But if the same line is edited by multiple people, human intervention is required to resolve the conflicts. So say Alice and Bob both tried to edit the same line. One said person 1 is the best person, one said person 2 is the best person. It will create this this file which has both of the options here, and then you just need to fix the merge conflict and then commit the corrected version. So once again, this sort of overview of this workflow is just to pull the latest version from the central repository, modify the code and document on your local repository, commit your changes as you make them, pull, again, to resolve any merge conflicts that might have occurred while you were working on your code, and then you can push your changes to the central repository, and then you can repeat. So once again, I'll give a quick demo of how to do this sort of workflow with SmartGit. So I'm going to SSH into my home computer. Ignore all the errors that it tells me. It'll be fine. Okay, so I CD'd into the place where my repository is, called QRepo. And now I want to do git pull to see if any changes have been made. So we can pretend that I'm another person on my home computer here. Oh, excuse me, I didn't actually push any new changes. So remember, before I made changes to my repository on the grid plot code. So now I can push these to the central repository so that others can access them. And now if I do git pull on my other computer, it notes that there has been a change to gridplot.py. One file change, one insertion, 0 deletions. I can do git log to see what happened. Here we see I added a nice comment. Very nice. So let me make a change on this computer. Added another comment. I never use that, whatever. So now I can do git commit gridplot.py -m. There we go. That is committed. Then I can do git pull just in case someone has made changes while I was working on that one file, which nobody should have. Then I do git push. And now back on my laptop, I can go through here and do a pull. And let it crunch through. Okay. And now I can take a look at the log and see that I actually did add another comment on another computer. So if this was someone else, oh, actually you can see that. I've got two different author names here. Adam N. Morgan is my laptop. Adam Morgan is my desktop at home. So this is like an example of how you can have two different people or one person on two different computers collaborating on the same code. Right. Any questions about that? Okay. Not a keynote. Thank you. Oh gosh. So there's a few more complex things that we can get into. I did not have this formatted correctly. So different things that that we can that you can do with Git that I'm not going to go into too much details, but just wanted to let you know that these options are out there. If you want to go back and undo some changes that you've made to a particular file, say you've committed something and you screwed up or something, you just want to ignore any changes that you've made after a particular commit, you can do that with something called a git reset --hard. And you need to specify which commit you're going back to with the last few digits, or sorry, the first few digits of that sh1 hash that we mentioned before that each of these commits is identified by. So this reset --hard will load an old commit and delete all commits newer than the one just loaded. So this is a kind of a dangerous thing to do unless you really know that's what you want. If you want to check out an old version of the code and be able to play with it and see how it ran, you can do git checkout and then specify the first few digits of the hash. And this will load an old commit, but any new edits will be applied to this new commit and will go down a different branch. So your other edits that you made after the fact, after this old commit, will still be accessible. And there's this git revert, which say you make a lot of changes to your local repository, but then realize you don't want to do anything with them. You can just revert, and that'll go back to the latest version from the repository. So say you made a bunch of changes and realized, or maybe you made a bunch of changes when you were drunk and you don't want to commit them and let people know that you were drunk when you made those changes. Just revert back to the old repository.
How do you know the first digits of the hash of some previous version?
You can get them from the log.
Okay.
So if you do git log and then you scroll down to where if you had nice commit messages, then you can see at what point. You look at the commit message, or you can look at the if you do a diff, or if you go back to Smart Git, you can pull up. If you just double click on if you go through the log, it will say all the different commit messages. If you double click on one of those, then it will pull up the state of the file as it was at that time, so you can see what the state of the file was, and you can go back to that. With Smart Git, again, it's much easier because you can just say, I want to check out this file, click, and then it will check out that file. But this is what you do if you want to do it from the command line. There's also branching if you want to take things down a new path, but leave a current version of the code as it is and just modify it, but not commit that to the same code base over and over again. You can do what's called a branch. And just go down a different path with your code. If that and say you want to test out a new algorithm, you can switch to a new branch and do development on this new algorithm without affecting the other branch of the code, the main one that people are working on. Okay. And then after the fact, if you decide that you want to merge that branch back to the main part of the code, you can do so with this merge. I don't really do any of this very often, but it's out there.
So do they have different names, or how do you know?
Yeah, you give a branch a particular name. So the master branch is the one that is the main branch for that code base. But if you want to make a new one for testing purposes or something, you can give it a new name and start playing around with that. So there's lots more that you can do with Git as well. There's also things like you can get help from all subcommands. You can browse through all your history, change history if you want. If you want to change the commit message that you made before, you can do that with something called rebase. You can also work with other version control system tools. I used to use Subversion, so all of my code base was version controlled under Subversion, but Git allows you to take that code base and import it all within the Git framework. So that was really nice because I wanted to start using Git, but I had already made all these nice commits and had all the history and stuff, and it allowed me to take all that from the old code base. There is advanced collaboration features, of which I know nothing about. And other things like you can tag a version of your code with a particular version number. And there's also some shell script tools that you can use. So in conclusion with Git, version control is awesome and you all should do it. Git is a free, actively developed, distributed version control system, which I highly recommend. Graphical user interface tools like SmartGit make it even easier to use. There are online repositories like GitHub, which allow for free backup of your code base and easy collaboration. Although it's only free if it's open source, so if there's any code or, say, papers or something like that that you don't want to be publicly accessible, then you probably don't want to use the free version of GitHub. But there are paid options available if you want to store things on the internet. Or you can just set up a server that everyone that's collaborating has access to, and then you can do everything through SSH. And the mantra of pull, modify, commit, pull, push, repeat. And here are some of links to obtain all this stuff that I mentioned before. This Git Magic book, I think if you're new to Git, is a great online resource introducing everything. Cool. So any questions about Git? We've got, okay. So I'll just go into the homework now. 3 homework problems here that I've set up. The first one is to go onto one of these free online hosting services, such as GitHub, and begin Git version control of your homework for this class. So you can create one folder for each of your homeworks. So, you know, homework 1, homework 2, homework 3, etc. And you can add all the previous homeworks as well. And as you make commits on your local clone, on your laptop or on your desktop, you can push all the changes to the online repository. So from now on, or at least for this week, you can turn in your homework for this week by sending an email with us, to us with instructions on how to clone this repository. So create this repository on GitHub, inputting all your homework files into it for this week and for previous weeks, and allow us to clone the repository from GitHub to our local computers. Homework number 2 is to begin version control on one of your own coding projects separate from this class, just so you can start getting in a habit of doing this for your own work. It can be a research code or journal article, a project, thesis, or everything that you do, which is the ideal solution. You don't need to send this code to us, just send us a copy of the Git log so we know that you're actually doing it. And all we'll be looking for here is that you're making a number of commits and actually are using this for development. Just for the goal of continuing on using Git in your everyday life or some other version control system.
Can you tell them about the single line sort of summary statement for making Git commits, and then also, you know, basically you need space after that so that they're going to do the longer version of it. So typically, like on GitX, which is what I use to visualize the branches and merges, you'll see one line which summarizes the log of that change. You don't want to say, I changed that. Right? You want to be as descriptive as possible and be sure to fewest number of words as possible. But then typically, if you're being really good about commenting, you'll add a space after that, and then you'll write a longer description of what it is that you actually want to change. But when you're saying descriptive commit messages, we'll be happy if you just make it anything more than I just changed this line. If you say, now this has a new functionality, the next version should use it. That would be a reasonable commitment.
Good. And then finally, back to the argparse and module stuff. We're going to be reusing some of the old code that you guys had developed. Was this the last homework or 2 homeworks ago? 3 homeworks ago? I think it was homework 5, using the database homework. So Chris has uploaded the latest prediction data from InTrade onto bSpace. So you can download this prediction data into the homework folder for this week. So this is this homework 7 or 8?
This is homework 8.
Okay, so this is homework 8. So download the latest prediction data into this homework, and without moving the base code from your homework 5 folder, so leaving all of the functional, all the modules and stuff that you put in that folder the same. Load the necessary functions from that code into a new module for this week's homework folder, and then set up a parser with argparse, allowing the user to retrieve information from the database in a user-friendly way. So keep all your homework 5 code in a separate folder, set it up so that you can import functions and modules from that folder to do the various database stuff that we want, and then set up an argparse set up so that we can call, say, create a function called electionpredictions.py, and we can call this from the command line minus C Obama minus date March 28th would print out Obama's closing value from the prediction date on March 28th. And also include a option minus P or minus minus plot, which will show a plot of all the predicted values from the candidate over time with the value at the specified date highlighted on that plot. And just include all the necessary checks to make sure that the user's path is set correctly to import the code so that when we try to run this in our computer that everything will work correctly. Is that clear? Questions on that? Okay, great. Good. Hello, I'm Adam, and today I'm going to be talking about Python application building and version control, 2 slightly different topics, but we're going to start off with a little bit of application building using command line parsing using this module called argparse, then get it into a little bit about how we can break up our different codes into different modules and packages to make things a lot cleaner and neater. Very briefly talk about debugging and testing. I don't have a whole lot about that. And then the second half of the class, I'll be talking about version control, specifically with the Git version control system. So starting off with argparse, you should all hopefully have access to this module already. What this allows you to do is simply be able to call programs from the command line that you make with Python, so you can just send off this standalone code to anybody and just give them a set of instructions of how to run a particular code with it. And you can specify certain options in a nice format here, and it will nicely parse all these different functions for you. So this goal is to just build this standalone code base in Python with command line options and keywords. So this module argparse has been built into Python 2.7 and above, also in EPD, so you guys all should probably have it. If you don't, you can just do easy install argparse. And I also had a a sample code that you guys can download from the bspace that we'll go through in a little bit. And also the breakout session is on there as well, so if you guys want to go ahead and download that at some point. So this allows for user-friendly command line interfaces, leaves it up to the code to determine what the user wanted. You can be kind of flexible in how you specify these different options, and the code will parse them in a nice way. And it can also automatically generate help messages if you screw up. If you type something that it can't recognize, it'll barf and say, I don't understand what you're trying to say here. Here are the options that I'm allowing you to give. Please try again. There was also a quick note on this older module that some of you may have seen before called OptParse, which is basically a similar thing, but it's not 100% compatible, and I think it's being edged out in terms of rGParse. So the first step for setting up rGParse is to just create a parser object and tell this object what arguments to expect, which can then be used to process the command line arguments during the runtime. This parser class is called argument parser, and what this does is just take several arguments to set up the description for this particular variable. Then you can set it up this way. And yeah, going back to Josh's point that we can specify what we want. It would be, there's a flag here, like I think it's called type, where you can specify whether you want it to be an int or a float or a string or something. By default, it's just a string.
Yeah, I could imagine maybe making it a bunch of default values. So, but I don't think you can do that.
For what?
Like if you say -c, that loads all the default values. Maybe not.
Oh, for the constant store?
Constant value.
For this guy?
The other one
Yeah, you can well, this one, it expects that you give it a string input. So if you look back at the help file, it would say, to run this, you do python program.py -s, and then type a string. And then it will try to parse that string and assign it to this value, this variable simple value.
Or you can retype it within an argument, right? Like you have to type in a string because the command line input has the string.
Correct.
Like if you type a number and you say convert this to a float and add argument, it'll do that, right?
Yep. And if it can't convert it, then I think it'll give you a nice error message saying, I don't understand that input. I expected an integer. Okay, so store true, store false. These are just Boolean switches. Here we see we can give it a default value if we want. So here the default is false. So if we set this flag -t, then it will change this Boolean value to true. So you see the Boolean switch is now being printed out as true. Append, this can take a series of entries on the command line, and then it will append all of them onto a particular list. So these will all go to the list collection. So here our command line input is Python rGParse action.py -a1, -a2, -a3. So then these strings 1, 2, and 3 will all be appended to this list collection. So when we print out the list at the end here, you see that they have all been assigned to this collection list. And similarly, append constant, here we define hard-coded what the different values that we can append are. We went through the different steps of importing the rGParse module, setting up our parser object, parser equals rGParse, argument parser, gave it a description. And then we added all these different arguments, giving them the flag that we expect from the command line, the action that this argument is supposed to perform, the variable that it's going to be appended to, which is this destination, and a little help string. Josh, do you have a laser pointer by chance?
I might, yeah. Do you want to say the difference between store and store constant?
Yeah, so store takes the variable that you define in the command line. So for instance here, the command line would be Python, whatever this file is called, -s to denote that this is the flag I want to parse, and then a value. So I could do Python code.py -s variable name. And then the string variable name will be stored to the destination simple value. What store constant does is you have a predefined constant here, which is hard-coded into this code base. So all you would set here is this -c flag. You wouldn't give it a variable afterwards. All you'd say is Python code.py -c, and then this value store constant would, or sorry, this value to store would be assigned to the destination constant value. And we'll go through what these different things do. So gone through here and defined a bunch of these different actions. We got the store constant, we got the store true and store false, which are the Boolean ones. Append, which appends things to a list. The destination collection, which is the variable. Append constant and minus version. And then all of these results are in this, we can assign all the results from the parsed command into this parser.parseArgs object. So these go into the results object, and then they are all values of this object, all attributes of this object, defined by their destination. So if something was stored with this -s command, then it will be put in results.simpleValue, and then we can print out simple value. Similarly, results.constantValue, results.boolean switch, results.collection, and results.constant collection. Using the help text of the Python program. So just starting off simply here, all you do is import argparse, set up your parser object using this argument parser class, and you can give it a little description if you want. And then what we do with our parser object is we go through and we define different arguments that we expect the parser to expect and be able to handle. So we use this function addArgument in the parser class. And there are 6 different supported actions, which I'll get into on the next slide. And then once you define all these arguments, the command line entry is parsed by passing a sequence of these arguments that you give on the command line to the parser object. And these will just be taken from the command line by default. So going through the different actions that can be defined, there are 6 built-in actions that can be triggered. The simplest one is just store. What this will do is if you give it a value, it will just store that value into some variable. And if you want, you can convert it to a different type. So by default, things on the command line are just parse as strings, but you can say, I expect an integer here, so please try to convert it to an integer. And if it can't convert it to an integer, then it'll give you a nice, friendly, helpful error message saying that I can't understand what you're trying to give me. Another action is store constant. This is slightly different in that this is just a single flag. So if this flag is set, then a constant will be stored that's predefined, hard-coded into the parser program. Store true and store false are just save the appropriate Boolean value, whether you want this variable to be assigned true or false. Append is a neat one. You can save values to a list. So you can specify several different variables, and they will all be appended to this one list function or list variable. And similarly to the store constant, you can specify this append constant, which will append a bunch of predefined variables within the hard code to the list. And finally, version just prints out the current version of the program and then exits. So there's this. This is the file that I uploaded to bspace that we're going to go through one by one to see these different argument actions in practice. So here. And there's also this nice argument help, whereas if we just specify, so this code that I uploaded was called argparseaction.py, which is what we just saw. So if I just do on the command line Python argparseaction.py minus h or minus help, then it will print out all of the different arguments that it can accept, and it will give you a little help string that you defined in the code of what that flag does. So here you see minus s simple value will store the simple value you specify here into this variable. So going through these different slides, or these different options here, starting off with store. If we give the command line argument Python argparseaction.py minus s value, what this will do, and then as you remember at the end of the code, we printed out all the different variables that we're storing here. So simple value gets the string value gets stored to simple value. We didn't do anything with the variable constant value, so that's still none. Boolean switch was defined to be false by default. Collection is still empty, and constant collection is still empty. So going on to store constant to delineate the difference between this and store. Here we just give it the flag minus c. And what will this do? So this simple value is none because we haven't defined that. So what will the destination constant value be stored as? If I just gave it the flag minus c, the constant value to store is hard-coded as the constant that we want to store to this destination. So as we go to the next line, constant value, you see the value has been assigned value to store. Does that make sense?
And that could be anything. That doesn't have to be a string.
No, that can be anything.
A number, it can be a list.
Absolutely. Yep.
So it already knows the value that you're asking it to store?
Yeah, that's hard-coded. So this is something like, I don't know, if there's for some reason you want to have a flag that this flag will only do one thing and will only say like, I don't know, like if there's this string that is later used in your code and you want to be able to have a flag saying please assign this string to this value or this number to this value, then this will just allow you to do it with a simple flag rather than having to input the value you want. So this is something like if you, the coder, know that there's only one value that makes sense,